In this video, we present SuRE, an interactive visual tool that helps you explore and understand black box models. The system in front of you is the user interface of SuRE, with the least number of rows that cover the behaviors of your model on the whole dataset. This interface consists of three parts: settings and legend, row table, and a graph of subgroups. Now let's focus on the row table and have a look at the rows that are generated to describe a model which predicts whether a loan applicant will default in the future based on his or her credit records. In this case, red represents a positive clause of default, and blue is for the negative clause of not default. Here, each row is a rule, and the rectangle in a cell shows the condition of the rule combined with a corresponding column. For example, here this cell shows the range with high values of bills paid on time. More specifically, as indicated at the bottom of the table, it means bills paid on time larger than 95%. Similarly, this means average months in file smaller than 102, a range of relatively median and low values. For each row, we can find a subgroup of instances in the original dataset that match this rule. And on the left side of the table, there are a few visual components showing the model behaviors in each subgroup. The first is the estimated prediction of the original model for a subgroup, which follows a confusion matrix of the original model's prediction in this subgroup. And then the bar shows the support of a rule or the number of instances in a subgroup, and we have the fidelity of a rule in the end. In this system, we can sort the rules by prediction. And now we can see that for the subgroups with a prediction of default, most of the applicants do not have a high value for bills paid on time, and usually have a relatively high unpaid balance. We can also sort the subgroups based on confusion matrix to check where the original model performs well or poorly. Or we can sort by support to check how the subgroups with the most instances look like. Also, we can sort rules by conditions so that we can focus on one feature and its relationship with the predictions. Here we can roughly say that low values of unpaid balance are mostly relevant to not default, while a high unpaid balance is relevant to default. Last but not least, we have a graph of subgroups on the right-hand side of the table. Here, each node represents a subgroup, and the more instances in a subgroup, the larger the corresponding node is. Similarly, the width of a link in the graph represents the intersection of the connected subgroups. And the more similar the two subgroups are, the closer the two corresponding nodes are. In the process of exploring the rules, you may want to explore more specific and higher fidelity descriptive rules, and you can change the settings by clicking the gear on the top. For example, you can set the minimum fidelity of the rules as 95%, and you want to have more detailed rules so you can set the most number of features at 3. Now, you have more detailed rules as descriptions. And you can further explore the rules and semantically validate and understand the original model's behaviors.